Before we begin to dive into our car project, it helps to understand an important component which allows our car to move, the DC motor. In this lecture, we will be discussing DC motors so you will have a greater understanding of the underlying electronics principles of how they work and how they can be controlled. This is important because we will have to control the direction of our motors in code in order to drive our car. Let's get started. Here are the objectives for this lecture. By successfully completing this lecture, we will have mastered the following items. We will learn what DC motors are and how they operate, and we will also learn how the speed and direction of DC motors can be controlled. If you're ready to begin, then let's get straight to the discussion. DC motors operate due to the principle of electromagnetism. Essentially, when we apply an electric current to a wire or even a coil of wire, a magnetic field is actually generated. Current flowing through the coil will actually create an electromagnetic field with a north and south pole, just like a magnet. It is the interaction of these temporary magnetic fields with static magnetic fields of a stationary magnet that cause motion. Let's examine this principle of motion in a little more detail. As an applied current flows through the wire, an electromagnetic field is generated. When the electromagnetic field interacts with a stationary magnetic field of magnets that are in your motor, this results in motion. Have you ever felt the force when a north and a south pole of a magnet are brought close together? It is that magnetic force or attraction that results in motion and our motor spins. There is some more detail to the exact operation, but at a high level, this is how DC motors work. I will post some links in the resources section of the lecture so you can scan and read up on this some more if you're interested and get additional details. With regards to the speed that the motor spins, the stronger the current we apply to our wire or coil, the greater is the size of the electromagnetic field that's generated. This will result in a stronger push-pull with the stationary magnets, and this results in faster motion. Likewise, the weaker the current you apply to your coil or wire, the weaker the resulting electromagnetic field, and the weaker is the force of the push-pull that is experienced, resulting in slower motion. To change the direction that our motor spins, this process is simple. You just change the polarity of the power that you apply to the terminals of the motor, and it would spin in the opposite direction. The trick is, how do we control this and make this happen for our car project? That is where the Arduino comes in. We will address this some more in the next lecture. The type of motor we will be using for our project is a brush motor. The DC brush motor is one of the simplest motors in use today. You can find these motors just about anywhere. They are in household appliances, toys, and automobiles, and being simple to construct and control, these motors are the go-to solution for professionals and hobbyists alike. To summarize, in this lecture, we learned all about DC motors and how they operate. You were also introduced to how we can control the speed and direction of rotation of a DC motor. In the next lesson, we will look at specifically how the direction of motor spin will be programmatically controlled via the Arduino. We will need the help of a handy component to help us out, a motor driver. I'll see you in the next lecture.